So, thank you for inviting me here. Yeah, when Alberto and Peter approached me and us, ABB, to present in the conference, the initial thought was, yeah, we can share the experience and our support and advice that we, during our collaboration with MIT. But taking a step back, then and further thoughts, we said, why not trying to, because we know that whatever work was done and it was going to be covered by Princeton and MIT, I said, let's take a step back and look at the entire field. What is the warehouse and logistics? What's in ABB? What ABB was done? What's the current state of the industry? And then what's some kind of work that we are doing in this space so we understand the entire field. So my name is Remus Boca. I'm with ABB Corporate Research in Bloomfield, Connecticut. ABB, just one slide, just to introduce you what ABB is. So the main focus is 40% power and 60% automation. Power means low, medium, and high voltage. When you go on the side of the road, you see the big boxes. These are transformers, usually some kind of medium voltage. It's part of that side of the business. Automation means motor, gears, conveyors, robots, and also sensors and process monitoring. Lots of stuff. These are some of the data that you can see. Global company, headquartered in Zurich, and this information is online. Corporate research, and the group I'm in is focusing on mechatronics and sensors, and 90% of what we are doing is robotics. And we have three objectives, yeah. So look forward what are the future robotics applications and try to understand the trends, and do pilots and evaluate the technology. So when the technology is ready, you can transfer to the business unit. Support the business unit as a second goal, yeah, support them with challenging application. And one of the third objective is to collaborate with external parties and universities. During the, so our goal was to, if you're looking at the future robotics application, you are looking at any application, yeah, and usually the standard applications today that we are kind of the most comfortable ones are the ones related to automotive market and general industry. So logistic is covered in a sense, but it's covered indirectly, but three applications, and these three applications from ABB, so just getting back. So as I said, so I'm trying to taking a step back and thinking about what's there and trying to find out, to understand what's I'm going to cover today. It's kind of covering what are the current state of the industry from the ABB perspective, yeah? What's the warehouse and logistics today? What would be the opportunities? And what are some of the needs in future from the industrial point of view, yeah? Oh, sorry. So, today, for example, from the ABB perspective, these are some of the industries that are related to warehouse and logistics, chemical, food and beverage, personal home care, pharmaceuticals, application times, picking, packaging, palletizing. I'll walk you through some of the videos to show what they mean. Type of products, you see bottles, boxes and bags, food, the same. And the robotics products that we have, and they are not similar to all the other ones, are industrial and collaborative robots, controller software, and Pigmaster. So here is what they mean application point of view. Picking is handling, but usually it's the category of product is restricted, yeah, and there are some reasons why that, but picking the high-speed products from a conveyor. Packing means picking and sorting it or placing it in boxes. Packaging means to order them and place it in boxes. So picking the right numbers to pick them in boxes, and palletizing means to create the pallets, to load the pallets or unload the pallets. And you can see at the bottom some of the applications, yeah, and type of objects. But let's go and see some of the videos. So this is, for example, for food and beverage. This is picking muffins, something you can see, or pretzels, and you see it's a high-speed picking. Yeah, it's the same. This one is packaging meat, and the same thing. Yeah, these are engineering lines. Yeah, it's moving at a very high speed. Here is the same. Packaging boxes with meat inside, sausages and raw meat. This is kind of like sorting spaces in cassolettes. And here is one robot. The tools usually are specialized bottles, handling bottles, different kind of bottles. And you see, because the tool usually are customized, just a note here, yeah. And they depends, because that depends on the application, yeah. So this was food and beverage. Some other example of applications. Here it's a custom to electrical products, yeah, and you see the tool for this application. Here there's an additional degree of freedom, just going down. This is furniture packaging or packing, and you see lines. This system are engineering in the sense that everything is controlled here, yeah. It's control to the second or milliseconds and position, specific tools. This is a view from outside how this is packaging, I'm guessing, picking boxes. And it has a little bit of flexibility, but not that much. You see the tool can pick one or more boxes at a time, and these are another example. For example, the robot is on a track. It needs to pick CDs, picking and packaging. Here is the same palletizing. Paint, drums, again specialized tools, heavy payload robot. And you can see here, some of these jobs, they don't require advanced functionality. They are simple. They just require, this is more or less is packaging or also material handling, yeah? So they do not require advanced functions, just to, and the parts are indexed in a sense, just to pick them in place. Here is you are going to see a specialized gripper that it can pick objects that are not aligned. It's an interesting engineered solution. You'll see right away how don't ask me why it was decided to be done this way, but it's just maybe to increase the cycle time. I don't have all the data. Okay, this is this is about the luggage handling. It was done in it's a hotel in New York. But besides the robot, the rack behind, it's quite engineered, yeah. It's a special rack. The parts are in the exact location, in the right position, and the robot is not handling the luggage, it's handling the shelf. Maybe I should let the sounds to this one. I can explain. So years ago, I worked for a different company for brain tech, but corporate research and brain tech, we had a demo. Actually, it was a pilot. We were supposed to do it for Toyota, but in 2008 the market was down. the system was there, but it was postponed, and then it took a long time to recover for the economy, and then we did not have a chance to test it in the real production. But we showed this demo at IMTS. So it's a full beam picking system, and it was we worked with the con rods for the automotive. So it was an okay. The tool has some compliance. It was a 3D camera bumblebee. You can see embedded in the tool. The robot was moving around, taking many images, detecting hypotheses, calculating the grass positions, checking which one is visible, checking for collision, planning, grabbing it, and then dropping. At the IMTS in 2008, I'm not sure if you are familiar, this is one of the largest manufacturing show. It was quite a success, but unfortunately we were not, at the time, I wasn't working for ABB at the time, but they did not do it they did not convert it in the product. When people are looking at beam picking, usually they are seeing picking up the parts from the bin, and you through Amazon picking down the same thing, but here, it's also what's important is the dropping accuracy, yeah? So you can see here the parts, and not only dropping, but the parts needs to be sorted before they are dropped. So, with the shoe that you see there at the end, it is designed so the parts at the end, and for the cycle time too, yeah? The parts at the end are oriented. Okay, so now, just switching to the newest robot. This is a video about a demo that was done last year in Italy for the supermarket, kind of future of the supermarket, and handling, if I can find my mouse. So this is the newest collaborative robot from ABB. It has a robot tool from AWL Robotics. It's a pneumatic tool. It's just to pick, let's say, an uniform object or soft objects. Now, to take a step back, and maybe you have the same experience now, it's great, the demo looks great, but you do not see, even for Amazon Picking Challenge, or even for demos like this, is that, what you start to see, and we'll see in the next, it takes some time to train the robot. Yeah, and that training time, it's one of the bumper, to say, the blockage for the robot adoption. So it looks great, but there is a lot of effort engineered to make a system like this working. So, what are some of the if we'll have to summarize, yeah, the applications that you see, they work. That's it, they work. But, so you can see solving many different applications. We are talking here about fast motion. The system are reliable and robust. Robot tools are optimized for a part or group of parts, yeah? On the downside, it takes time to implement, train, and test. That's the nature of it, yeah? The systems are specialized. These are custom solutions. It's hard to take one and place it in another one. And the number of application installations sometimes is limited. And this is from my experience when I work for BrainTech, and also for ABB a little bit less because I'm on the research side, but for BrainTech dealing more with the customer, every time we had a new application or part, every time we had a new part, even if we say the system is generic, can handle anything, it was like a new application. We need to test the part, we need to be sure it works, 24/7 with the right accuracy, because of many variations. Maybe the features that the part has, they are not proper, the lighting was changing, maybe 2 robots instead of 1 robot. So, but this is just to give you an idea where we are today, yeah, where systems are working, but sometimes they are expensive, because this is coming down here at cost, yeah. That's what it means, yeah. So now, looking forward to what's about the warehouse, yeah, and just going and looking around, I collected some of the operations that they look. So this is like, it's huge. This is how a warehouse looks. I think this is Stretchers in US. It's a huge, you see, the boxes are coming at high speed, yeah. This is material handling more or less in a warehouse, manual work. And now there is a difference, there are two types. One is the horizontal storage, the density, storage density. It's horizontal or it's vertical. In Europe, it's more or less because of the space constraints are more vertical. In US, because the space is not a big issue, it's more horizontal, yeah. So, but you can see here people going around. This is a vertical and goods to picker type of system, vertical system. Parts are brought to the operator to handle them. There is a lot of variation out there, yeah. We know all those ones, yeah. And especially it's what's driving this one, and in a second you'll see what's driving this one today. It's the studies are saying that online retailing requires more human labor than shipping in bulk to stores, because you have to handle more individual packages for each customer. And this is kind of one of the drivers for automation. And the other interesting thing, it's only 5% today of the warehouses are automated. And you can see here, anything, yeah, everything is milk warehouse. Parmalat, I think, is this one. Port, boxes, warehouse, in transit. Somebody needs to do all this work. I'm guessing this is it. So what are some of the drivers? So as I mentioned, is the online retailing, low automation today. But what is shocking to me, amazing at the same time, is that in this inbound logistics, and then coming from the MHI consortium, they are saying that the size of the market is 1.3 trillion. So, in my opinion, there is a lot of opportunity there, yeah. Now, before I finish, I have a demo to show it to you, because when you look from ABB perspective, and when you look at logistics, and we were looking how the robots, what are the requirements on the robot side for future factories, yeah? And it also is going to be a paper. Just I'll show you briefly. Also, maybe you might not see it. You'll see it in a second. I just need to do quite. Also, it's going to be a presentation Tuesday afternoon, but just to show it to you, what does it mean? Usually, there are risks when you do everything online, yeah, but that's okay. This is a study we did years ago, a couple of years back. So what's here? So we look at Kiva concept, and we said, what's how we can take that system and extend it to a factory, yeah? How we can take that system and to extend, and there are some constraints in addition to just the warehouse. So a factory was divided in 4 areas: parking and charging, loading, production area, and delivery. And then also we have, you can see there is a traffic management with exactly as a normal traffic road system with 2 senses. But at the end there is a recipe, production recipe, the part needs to follow to be manufactured. We have some constraint. Each cell, it needs to be up 100%. So we had queues in each cell to ensure the productivity. And at the end of the day, the conclusion is that in order to move towards these targets, we need somehow to upgrade the robots that we have today. And one of the main things is to not only to make the system easier to update it from a capability point of view, enhance them with sensing, perception, awareness, communication point of view. The robot shouldn't be only by itself, it should communicate in a high-level way to other robots or the additional nearby equipment. We need a very advanced scheduler. Here, and the reason here is that it's the same as in the other system. The idea here is that in today's system, in today's plants, most of them are conveyor-based, yeah. But in this case, if one cell or one system is down, then it's just a software change to reroute the production flow. Let me stop this one. So before I end, I have one more slide. Searching and looking around to see what's going on, what's the future of the warehouse. Come across this report by AWL, Robotics in Logistics. And I'm not sure if you are familiar with in early 1900s, it was this future of the vision of the future for the year 2000. DHL did something similar, yeah, maybe on a shorter time scale, future vision for the distribution center. And I suggest everybody should read the report, but at the end of the day, here, what they are saying here is it's going to be an autonomous transportation system, and then autonomous picker to picking part individuals. Here is goods to picker, autonomous goods to picker. What else is here? I'm trying to figure it out where it's for. Oh yeah, this is an autonomous maintenance robot on call if something happens. Then we have the packaging, and you see it's a collaborative robot. We have this skeleton. What else we have here? 7 automated surveillance, drone delivery. I'm guessing the same vision as Amazon. And then there is one more, the swarm robots. More or less, and everybody today is recognizing the robot in automation was one of the factors, yeah, to improve the operation and to help with the challenges, future challenges, yeah. So, in conclusion, there is no question, there is no secret that ABB is interested in collaborative robot, as you know, yeah. We released a robot last year. We also bought a company last year, Roberta. So we are moving forward in this domain. At the same time, we are here to listen, to learn. At the same time, from corporate research, ABB corporate research point of view, we are looking for strong partners to move forward. And if you like to know more, or please just talk to me or one of my colleagues.
Thank you.